Rhombus, circumscribed, angles, this thing. It's geometry. With me, Miss Cohen.
Today we are doing our fifth lesson in this unit, Unit 3, Lesson 5, rectangles, rhombuses, and squares. So I'll give you just a moment to get that into your table of contents, and if I go too fast, feel free to pause. So last class we learned about parallelograms, and today we're learning about rectangles, rhombuses, and squares. And it turns out those are all just actually special types of parallelograms. So instead of turning to a new page, I actually want you to find this page from your last video, which has this foldable that we just began. So we talked about parallelograms last class, and then today we're going to be doing rectangles, rhombuses, and squares. So the first thing that I want you to do is actually make like a little fix, because on this foldable it says that a rectangle is a quadrilateral with blah blah blah. Actually, we need to get more specific than that. It's not just a quadrilateral, it is a parallelogram. Okay, so a rectangle is a parallelogram with 4 right angles. So go ahead and fill that out on your foldable, and then if you want to make it cute, you can sort of highlight what it is that we're talking about. So that's the definition of a rectangle. So what I want us to do right now is open it up, and we're going to talk about the properties of rectangles and the conditions of rectangles. So first, the properties. So if a quadrilateral is a rectangle, so if you know something is a rectangle, then these things are true. Obviously, it's going to have 4 right angles. That's the definition. But in addition, there are some properties. So the first thing to know is that the diagonals are congruent. And so we're going to need to show that in some way. The first thing we're going to need to do is draw in the diagonals. So go ahead and do that. Please use a straight edge. So there's one. And there's the other. So if you know you're dealing with a rectangle, and we should draw in that this is in fact a rectangle, then you know those 2 green line segments that I drew are congruent. And so in order to talk about that, we really need to label the 4 points so we can write some congruent statements. So we're going to go A, B, C, D. And then this property says that AC, that's one of our diagonals, so line segment AC is congruent to line segment DB. So that's useful. If you know you're dealing with a rectangle, you know that that is true. In addition, the other property of a rectangle that can be really useful is that the diagonals are not only the same length, but they bisect each other. So they cut each other in half. So you're probably dealing with the same situation as me, which is that this is in the crease. But we'll do the best we can to draw in these diagonals. There's one. There's the other. And this time, I don't think it's necessary to write out the congruent statements. Let's show that it's a rectangle. But I do want to show that each of these diagonals is cut in half. So this diagonal got cut in half by the other one. That means those segments are congruent. And then this diagonal got cut in half. But since the diagonals are equal, if you cut 2 equal things in half, then all the little halves are equal to each other. So what we have there are 4 congruent little mini line segments. Okay, so the diagonals themselves are congruent, and then each one is cut in half. So those are the important properties of rectangles. And then over here, we have conditions of rectangles. So just like last time, this is what you know to be true if you know you're dealing with a rectangle. Here, what if we're trying to figure out if a shape is a rectangle? So it says here, a parallelogram is a rectangle if, and then there are 2 additional ways you can know that it's a rectangle. Obviously, if it has 4 right angles, it's a rectangle. But additionally, all you really need to know is that one angle is a right angle. That's all you need. If you have one right angle and you know you're dealing with a parallelogram, then automatically you have a rectangle. Now the key is that you already know that this is a parallelogram. So I want you to just draw an arrow and say parallelogram. So one of the conditions of parallelograms would need to be true as well, right? We have these 4 conditions, or we could use the definition that we've got opposite sides parallel. So if you know you're dealing with a parallelogram and you have one right angle, you have a rectangle. Additionally, if the diagonals are congruent, then you know you're dealing with a rectangle. And so that's the converse of one of those properties. So if we've got diagonals that are congruent here, and we know we're starting with a parallelogram, then you can be sure that parallelogram is a rectangle. And so I'm going to have to label these again to show congruence. So if AC is congruent to DB, and we started with a parallelogram, then we can be sure that it's a special kind of parallelogram called a rectangle. So before we move on and do the rhombus and squares, I want to do an example using just rectangles. And so now I'd like you to turn to a new page. Should be, so there are my examples from last video. And then on the new page, I'd like you to get it set up just like this. So I have the date that I'm making the video. You put your own date on there. This is Unit 3, Lesson 5. There's the essential question. And then go ahead and get example 1 copied down. So at this point, pause the video. Please get all that copied. And when you're ready, go ahead and return. So let's go ahead and work through this example. So the first thing we need to do is identify what sort of shape we're dealing with. So are we dealing with just a parallelogram or something more specific? And here I hope you can see that because we're dealing with 4 right angles, that's the definition of a rectangle. So this is a parallelogram, it's also a rectangle. And so we can use some of the properties of rectangles to find some of these lengths. So first of all, it's asking for CD. And because we're dealing with a parallelogram, if you look back at the parallelograms and we look at our properties, one of the properties of a parallelogram is that opposite sides are equal in length. And since rectangles are parallelograms, we know that's going to be true for a rectangle as well. So it's asking for the length of CD, and since opposite sides are congruent, CD also has to be 8 centimeters. And that's something you've known for a long, long time, that in a rectangle, the opposite sides are congruent. Now for AC, that's a diagonal. And so I'm going to flip back to my little foldable and look for what are the properties of rectangles that are going to be useful here. And so there are 2. One is that the diagonals are congruent, and one is that they bisect each other. So here, I'm looking for this entire length of AC. That's a full diagonal. And so what I know here is that the diagonals are congruent. The problem is that's not so useful for me because I don't even know what one of them is. And so I hope you can see here that we're dealing with a couple of right triangles. So AC is this length here. Well, we know that AC is congruent to DB because that's a property of rectangles, and we know that DB is the hypotenuse of this right triangle. That guy right there. So if you want to highlight it, you can. So I'm going to start by finding the length of DB. So to show my work really clearly, I'm going to say DB and then like a colon to show what I'm finding the length of. So DB is the hypotenuse of this triangle. It's the longest side, and it's across from the right angle. So A squared plus B squared equals C squared. I'm going to replace A and B with 6 and 8. The hypotenuse is the side that I don't know. So at this point, I would like for you to go ahead and pause the video, figure out the length of C, and then see if you can finish both of these questions. What is the length of AC, and what is the length of DE? Go ahead and figure that out, and then come back when you're ready. So I worked out the rest of the Pythagorean theorem here, figured out that the hypotenuse of that right triangle is 10 centimeters, and so that's the length of DB. So knowing that DB is 10 centimeters, DB and AC are congruent. That's a property of rectangles, so the length of AC is 10 centimeters. So hopefully you figured that out. And then the length of DE is just this piece. So our second property of rectangles was that diagonals bisect each other. And so that means that this piece and this piece are equal, and since the whole thing is 10, these each have to be 5 centimeters. And so that's the answer here. So that's rectangles. There's a lot more that we're going to do with rectangles, but for now, I'd like you to go back to your foldable, and we're going to talk about what a rhombus is. So a rhombus, I don't know if you've learned this word before, but a rhombus is what you formerly knew as a diamond. And so a rhombus is, again, we need to cross this out because it's not a quadrilateral with something specific, it's a parallelogram. So we're starting with the understanding that we're dealing with a parallelogram. A rhombus is simply a parallelogram where all 4 sides are equal in length. So we're going to write 4 congruent sides. And it makes a diamond shape when all 4 sides are the same and when you're starting with a parallelogram. So rhombus is a parallelogram with 4 congruent sides. So let's go ahead and talk about the properties and the conditions of a rhombus. So first, if a quadrilateral is a rhombus, then these things are true. First, the diagonals are perpendicular. So let's talk about what that means. Here's a rhombus. So we're dealing with 4 sides that are equal in length, and we know it's already a parallelogram. So let's draw in the diagonals. One goes there. One goes there. It turns out that if you're dealing with a rhombus where all 4 sides are the same, those will always meet at a 90-degree angle. That's the first property. The second property is that the diagonals bisect the angles. So here we're talking about cutting angles in half. So again, we're going to draw in that diagonal. That diagonal cut both of these angles exactly in half. So we're going to mark that by showing that those 2 pieces are congruent and those 2 pieces are congruent. So we have these 4 little mini angles that are the same. And then if we draw in our other diagonal over here, this green diagonal cuts these obtuse angles in half. So these pieces, I'll give them 2 little tick marks. This is getting crowded. Okay, those are also congruent. So those are the properties of rhombus. And then you also should know that all other properties of parallelograms are also true for rhombuses because these are just special parallelograms. So let's talk about the conditions then. If you know you're starting with a parallelogram, then what do you need to know in order to be able to prove that it's a rhombus? So it turns out that if you know you're dealing with a parallelogram, so we already know this is a parallelogram, then all you need to know is that one pair of consecutive sides are congruent. Consecutive just means next to. So if this is a parallelogram, and I know that that side and that side are the same, then I know that I'm dealing with a rhombus. And the reason is that I already knew it was a parallelogram. So I already knew that these sides were the same, and I already knew that these sides were the same. So just knowing that means all 4 sides have to be the same. So here we're starting with a parallelogram. And then what do we need to know to prove that it's a rhombus? Well, it turns out if we know the diagonals are perpendicular, we know we're dealing with a rhombus. So let's draw that in. Okay, now we have a rhombus. We started with a parallelogram. We know that. Now we know it's a rhombus. And then if just one diagonal bisects a pair of opposite angles, like this, that is also enough to know that we're dealing with a rhombus. So again, we're starting with a parallelogram. Knowing this means it's actually a rhombus. So we're going to do another example of a rhombus situation. So go ahead and turn back to today's notes. And this will be example 2. So we're going to draw a pretty big rhombus here. It's difficult to draw a rhombus, so we're going to start with a parallelogram, and we're just really going to try to make all of the sides look like they're the same length. So I'm going to go about maybe 8. I'm going to make this big so we can see it. And then we're going to try our best Well, why don't I measure it? I have a protractor. Okay, that's 5.5 centimeters. So I'm going to come over here and make a segment, just kind of going off to the side, that's 5.5 centimeters. Okay. And then I'm going to try to make this parallel to the top line, 5.5 centimeters. And if I've done it right, when I connect it back, that will be exactly 5.5 centimeters because I'm trying to draw a rhombus. And that worked out pretty well. Okay, so you do your best. And we're going to label these angles V, W, X, Y. This length here across the top is 6m minus 12 units in length. This side over here is 4m plus 4 units. And then there's a bunch of other stuff we're going to do too. Let's draw in both diagonals. Okay. This angle right here is 20n minus 20 degrees. And this angle right here is 9n plus 4 degrees. So that's the setup. And then I want you to write underneath it, or maybe up here at the top, this is a rhombus. So that's given. This is a rhombus. Okay, so there are two things that we're going to do. The first, part A, we want to find the length of XY. We're going to find that length. So we're starting with the knowledge that this is a rhombus, and the most important property of a rhombus is its definition. All four sides are the same length. So when we're looking for side XY, we can really look for the length of any side. We don't need to be looking specifically for this one. They're all the same. And so I'm going to start by looking here and here because this is the information I have about side length. And these two sides, I don't know what they are, but I do know that they're the same. So this kind of is reminiscent of when we were doing equilateral triangle stuff. If these two sides are the same length, then I can solve for the value of m by setting them equal. So I'm going to start by saying 6m minus 12, that's one side length, has to equal every other side length. And so one of the other ones I was given was 4m plus 4. So I'd like you right now to pause the video. I want you to solve this equation, and then you aren't done. It didn't ask what's the value of m. It said find the length of xy. So go ahead and pause the video now, solve this equation, figure out the length of xy, and then come back when you're ready. Okay, we're back. So I solved this. I did a couple steps here at once. I subtracted 4m from both sides, and I added 12 to both sides, and then I got m equals 8. And remember, we're not done. We have to find the length of xy, but like I said earlier, that's the same length as all the other sides. So I picked the easiest one. This one looked easiest to me, and I plugged 8 in for m. So I did 4 times 8 plus 4, got 32 plus 4, which is 36 units. So that length is 36 units. So next we need to find, this is part B, we are going to find the measure of angle XVY. So take a minute, locate that angle XVY, see if we can figure out where it is. So XVY has V as its vertex because that's in the middle, and it's going to go out to X on one side and Y on the other. So we're looking for this angle here. Okay. So let's think about what we know. This is a rhombus, and one of the properties of a rhombus is that the diagonals bisect the angles. And so what I know is that this piece, whatever it is equal to this piece. So if only I knew what that was, it would be the same. The problem is I don't. This has an n in it, and I need to know the value of n to find the measure of this angle. And so I want to look, where else is n? So here's n. And it's really tempting to try to like set these equal to each other or add them up to 180 or do something random. But don't do that. Stop and think. What do we know about this angle? Let's look back at our properties of rhombuses. We look back at our properties of rhombuses. Okay. We know that the diagonals are perpendicular. And you can see right there from the picture, there's a right angle. So that's important. That n that we were looking at was not in one of the corners of the rhombus. It was right there in the middle. And so this is the property that's going to be useful for us. So looking back at this problem, this has nothing to do with the angles around the vertices of the rhombus. This is a right angle. That's something we know. That's a property of a rhombus. And so I can set up an equation ignoring this entirely. I know that 20 times n minus 20 has to equal 90 degrees. And so that's where we're going to start. That's a 90-degree angle. So let's set that equation up. 20 times n minus 20 has to equal 90 degrees. Let's solve that equation together. You do it on your paper, I'll do it on mine. So we got a decimal. Remember, that doesn't mean we did it wrong. It just means we got a decimal. So n is 5.5. So now that I know the value of n, I can find that angle that I was looking for, right? Because I know now can find this little angle, and that's going to be the same as this little angle. So let's find the measure of that angle. It's going to be 9 times n, which is 5.5, plus 4. So 9 times 5.5, I got to do that on my calculator. 9 times 5.5 is 49.5. 49.5 plus 4 is 53.5 degrees. So I know that this angle right here is 53.5 degrees, okay, which means this angle is the same, because one of the properties is that the diagonals bisect the angles. So we have to go finish up by talking about a square. It's going to just take a few seconds, and then we'll be done for today. So a square, back to our foldable. A square, again, we need to fix this. It is a parallelogram. Okay, so I think you know this already, what a square is. A square is a parallelogram with both of these things. Okay, it has 4 right angles and 4 congruent sides. So it is a parallelogram with 4 congruent sides and 4 congruent angles, specifically right angles. Let's sketch it really quickly. Okay, we've got a square. It has 4 right angles, so it's a rectangle. It has 4 congruent sides, so it's a rhombus. So a square is a rhombus, and it's a rectangle, and it's a parallelogram. So if we look inside at our properties, I actually just listed them all out because there's so much to write, but what I want you to put here is that a square is a parallelogram, and it's a rectangle, and it's a rhombus. So that means that all of the properties of parallelograms apply. So I listed them here. These are the properties of parallelograms. They apply to a square. The properties of rectangles also apply to a square, and the properties of a rhombus also apply to a square. So we've got a bunch of properties here that apply to a square. And then in terms of conditions, how do you know something's a square? Well, you have to prove that it's a parallelogram. So those conditions, one of those conditions has to apply. You have to show that it's a rectangle. So one of those conditions has to apply, and you have to show that it's a rhombus. So to show that something is a square, you have to first show it's a parallelogram, then show that it's a rectangle, then show that it's a rhombus. And that's how you prove that it's a square. So right now what I would like for you to do is focus on your summary. I don't have a lot of space here, so you could kind of shove it here or use the opposite page. But do go ahead and think about your summary. The essential question is, what are the properties and conditions of rectangles, rhombuses, and squares? You have them all listed for you. So this is your opportunity to kind of put them in your own words if you want to, or just copy them down if that's useful for you.